Okay, so our problem involves finding the area of a region of the volume of a solid when rotated around the line and the perimeter of the solid of the figure. So this is the figure that Mr. Chan is drawing.
So we're gonna draw two different lines or functions. One is x times e to the power of x to the power of 2, and which would look like this. And it intersects with the line y equals 1,
X equals
1 at this point. And the second line is y equals negative 2x. So this would be a linear function looking like this. Obviously, we know that it intersects. So this is.
And that is the region R. Yeah.
First, we're gonna do number A, letter A, and to find the area of R, we decided to first do to find the area of a border between the line y equals 0, x equals 1, and xe to the power of x to the power of 2. So to do this, we found the integral of from 0 to 1 of the first function, which is x e to the power of x to the power of 2. And we plugged in this in the calculator. Oh, dx.
Dx.
And we plugged this in the calculator, and it gave us a number around 0.859. So this is about. To finish the area R, we need to find the area bordered around y equals 0, x equals 1, and negative 2x. And so, because it's the integral would look like 0 from 0 to 1 of negative 2x dx, and the absolute value of this. Since it's positive and we want to add it, and if not, it would look negative. So instead of plugging this in, we just treated it as a triangle. We knew this would be 2, and this would be 1, and so it would be the Pythagorean theorem. It would be 1 squared.
Area of a triangle.
Well, this is the area of a triangle. Okay.
Area of a triangle.
Oh, we're looking for the area of a triangle.
Payaso.
Para esa parte.
Yeto, para de pegarme y.
Para esa parte empezamos, o sea.
No, hombre.
Lo cortamos. So we're gonna find the area of a triangle, which is base times side 1/2. So the area equals 1/2. The base, which is 1, and the height, which is 2, and therefore it would be area equals 1. So this equal to 1, and therefore the area of R equals 1.8.
Okay, so now question B asks us to write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated around the horizontal line y equals -2. So this is -2. So basically, figure R has to be rotated around this line, and it would end up looking a bit like this. let's say that this is y equals -2, it would end up looking like this, or a similar shape. So our approach to solving this problem was to use the washer approach, and so we had to find out the area of a washer this big, and we have to find the area of a circle this big. So the area of this big circle would equal pi. Yes, that big circle, highlighted for convenience. So it would be pi radius, which would be 2 plus this function, so x e to the x squared. And now the area of the smaller circle, it would have to equal pi times the radius, which is 2 minus this function. So it's 2 minus negative 2x, which would end up being plus 2x. So now we have to do the integral expression to make it from 0 to 1, and therefore the volume equals the integral 0 to 1. We can factor pi out over here, so it would be 2 plus e to the x squared plus 2 squared plus 2 plus 2x squared dx. So this would give you the volume of R if it's rotated around y equals -2. That was a test. See if you're paying attention, because it is not plus, it is minus. Because you have to subtract this smaller area. If not, it would not be a washer, it would be a circle.
Alright, for part C now, the question asks us to write an expression involving one or more integrals that gives the perimeter of R. So, we know the perimeter is going to be the area surrounding the surrounding R, the length surrounding R. And so we first wanted to find this line, this length. To do this, we used Pythagorean theorem, since we knew that it was a right triangle. So knowing that this part is 2, because the intersection here is, when you plug in for 1, is -2, 1 equals -2. So the length is 2, and then here x equals 1, so this part is, this length is 1, and so we do 1 squared, 2 squared, equals let's name this c squared. And so we have 1 plus 4, which equals 5. So 5 equals c squared, and so c equals the square root of 5. So this length here is the square root of 5. Alright, now we want to find the length of this line. And because we know that the length of this segment here is 2, then this point would be -2. And to find the intersection point over here, we need to plug in for 1 in this equation. So x e to the power of x to the power of 2. And therefore it would be 1 e to the power of 1 to the power of 2. And therefore it would only be, the answer would be e. And so the length of this length segment here would be e plus 2. Yeah.
So now we have to find the length of this curve. And to find this, we have the formula that the length of a curve equals the integral of a to b of square root 1 plus f prime of x squared dx. So we have to apply this to this curve, and the way to do that is, first we need to find f prime. So f prime of x And since this is a product, so we have to apply the product rule. It would equal e to the x squared plus e to the x squared times 2x times x, so x squared. And we can factor it out by factor out e to the x squared, so it would be e to the x squared times 1 plus 2x squared, and that would equal f prime of x. So the length of this curve would be the integral from 0 to 1 to the square root of 1 plus e to the x squared times 1 plus 2x squared dx. So now that we know this, we just add this thing up and we get that the perimeter.
This thing means the three sides.
The three sides, yes. The perimeter equals square root of 5 plus e plus 2 plus integral 0 to 1 square root 1 plus e to the x squared times 1 plus 2x squared dx. So that was our problem. We hope you enjoyed it and pay attention.
That was our problem.